Hello again, guys. What's up? How are you? Well, as you hear, we're going to discuss today about some IPv6 fundamentals, another great topic for your CCNA studies, or if you are just trying to refresh a little bit about IPv6, this could help you. I'm Agustín Ciciliani, and I'm with Firefly. Our goal is changing the way we learn, evaluate, and adopt technology. So a little bit about topics we're going to cover. So first of all, why IPv6? Usually, this is a well-known issue with IPv4, but just we're going to remind why we have IPv6 here. If we already have IPv4, it's working fine. Some of the changes and improvements of IPv6 from IPv4 in comparison. And then we're going to go a little bit deeper into a couple of things that you really need to know if you're going to master IPv6, which is the Network Discovery Protocol and the ICMP version 6 protocol as well. And finally, we're going to do some lab and explain some examples of things that we're going to cover. Okay, so as usual, our first topic, we start a little bit with some background, some history, what is going on with IPv6, what happened with IPv4. So again, the main problem, I'm sure you already know this, is that we have depleted the IPv4 network space. That means that if you do the math, IPv4 has more or less 4.3 billion of IP addresses, but nowadays we have around 10 billion connected devices, right? With IoT and everything's connected, mobile phones. I mean, this exploded in the internet. You can see here in thewire.com some statistics. If you want to check that out, it's a nice article. And basically, how this works in terms of assignments and how do we know that we no longer have more IP addresses. So basically, this is organized here with the IANA, and IANA basically works with the registrars that we have basically the whole world divided in sections, and each section assigns its IP blocks. Let me show you real quick the IANA web page. So IANA is the Internet Assigned Numbers Authority, and basically the IANA assigns IP blocks to the registries. We have AfricaNIC, APNIC, ARIN, LACNIC, and RIP, depending on the on the part of the world that you are or where you want to get the IP addressing. These registries basically manage that part of the world. So let's here we have an example from ARIN where it says, yeah, no more IPv4 addresses available, no more allocations. What we can do with this, the only things that we can do if you are a service provider and you have a very specific mission critical issue, you can actually ask for a reserved IPv4 block, or if you are actually migrating to IPv6 and you need an IPv4 block in order to go with that project, okay, you can actually ask for that, but no regular IPv4 block allocations anymore. So what we've been doing for the last 20 more or less years, a little bit more usually, in terms of how to manage this IPv4 depletion, well, we have used some techniques like CIDR and VLSM and NAT and RFC1918 IP addresses. So a little bit of CIDR and VLSM. If you remember, the first blocks, IPv4 defined blocks like I, A, B, and C. And the idea was to assign like a whole A range to a huge company, maybe a medium-sized B block, and then for small applications, block of class C. But then they saw, no, we're just wasting a lot of IP addresses if we assign a whole /8, which may be a lot. So we're gonna do this CIDR, which is from defining RFC 1817, which basically assign shorter prefixes from, let's say, from a class A, maybe we can assign, which is /8, we can assign, I don't know, /10s or /12s, right? So we can start splitting the whole class A or whole class B and make a better usage of the IP addressing. And then VLSM, where we can basically subnet these allocations in our sites, right? Basically to just address the amount of hosts that we're going to use. Then RFC 1918. So basically we have, if I'm sure you know the ranges, these are what we call the private IP addressing. So we basically can assign the same IP addresses. Every company can use the same blocks, right, for their entire company in a private way. This should not, or that's basically they cannot be routed to the internet. And we use NAT, right, when we have to convert these private IP addresses to routable internet IP addresses. This creates basically a couple of problems. First of all, because a lot of companies are using exactly the same IPv4 ranges, private IPv4 ranges. So when we have like merges, we have problems, or when we need to communicate with sites that have the same IP addressing, we have to start doing this NAT, right? So basically translate the addresses to help basically connect two devices to the same blocks, same IPv4 blocks, or use the internet with a routable IP address. So this creates some headaches in the operations, and when again kind of use cases like merging, or for whatever reason you have used the same IP ranges, so you start having address issues.